All right, so in this lesson, we're going to continue talking about exponents. We're going to talk about the power property, or raising a power to a power. Now, our power property states that when we have a base and our base has an exponent in it, then what we can do to the two exponents is multiply them. So for example, if I have 8 to the second power to the third power, that's the same as saying 8 times 2, which is 6, 8 to the sixth power. Right, so all you did from this step to this step is just multiply the exponents. Right, so from here to here. All right, and we did this because it's different from what we did before with, I don't know, if I had 8 to the second times 8 to the third. Right, here we actually see a multiplication, but this multiplication tells us to add the exponents, right? And that was in the previous lesson. Right, and that gets us 8 to the fifth, right? 2 plus 3. Right, but this looks a little different because when our base has the exponent, and we have another exponent on top of that. So this is when we actually multiply and not add. All right, so our example here is telling us that we're just using what it means to square something to evaluate something like x to the fifth to the second power. Right, now if you square something, that just means to multiply it by itself twice, right? So x to the fifth to the second power, right, it's going to be x to the fifth times x to the fifth, right? That's what it means to multiply. To raise something to a power is to multiply it by itself. All right, and then because we're multiplying with the same base, we can add our exponents, right? And that gets us x to the 5 plus 5, which is x to the 5 times 2, which is x to the 10th. Right, so that's where our rule comes from, right? If you understood the previous lesson, then this should be just a natural continuation of it, right? It shouldn't be anything super crazy. All right, and this just states our property, right? A to the m to the n is a to the m times n. All right, where m and n are rational numbers, right? They can be anything. So let's fill in these few examples, and then we'll do some for the remainder of the lesson, right? If I have 4 to the second to the third power, that's the same as 4 to the second times 4 to the second times 4 to the second 3 times, right? And then 2 plus 2 plus 2 is going to get you 6, right? So we can use our product property that we learned last time to evaluate that. All right, so then the next one, right, 5 to the fourth to the second, that's the same as 5 to the 4 times 2, right? Power to a power you can multiply. And then we get 5 to the eighth power. All right. Similarly with the next one, w to the fifth to the second, right? That's the same as w to the fifth times w to the fifth. And then 5 plus 5, that's going to get you 10, right? Multiplying with the same base, you add the exponents. All right. Now, m to the 1/3 to the fifth, right? That 1/3, you're going to multiply by that 5, right? Power to a power you can multiply. And then 1/3 times 5, right? Some people were confused about this in class. If you multiply a fraction and a whole number, you can write that whole number over 1 and then multiply straight across, right? 1 times 5 is going to get you 5. 3 times 1 is going to get you 3. So it's going to be m to the 5 over 3. All right, now let's just do some examples for the remainder of this lesson, right? So looking at this first one, z to the fifth to the third, we see a power to another power. That means we're going to multiply. So this is going to become z to the 5 times 3, which is z to the 15th. All right, nothing crazy there. All right, same exact thing with the next one, right? M to the 4th to the 10th, 4 times 10, that's going to get you 40. So this is going to get us m to the 40. All right, next one is v to the 7th to the 1/2, right? 7 times 1/2. We can do the same thing that we did in the previous slide, right? Write that 7 over 1 and just multiply straight across. All right, so then we get v to the 7 over 2. All right, and then k to the 4/3 times 3, or no, to the 4/3 to the power of 3, power to a power, you're going to multiply. And then once again, I can multiply a fraction and a whole number just by multiplying the top with the top, the bottom with the bottom. 4 times 3 is going to get you 12. 3 times 1 is 3. But 12 divided by 3 gets us a whole number, so we can simplify this as k to the 4th. All right? So hopefully you guys are getting the idea Any time you have a power to a power, you just multiply the exponents. All right, so let's keep going. This next one, x to the 7th to the negative 2. Again, we have a power, r7, to another power, that negative 2, so you're going to multiply. This is going to get us x to the negative 14. But anytime you have a negative in the exponent, you want to bring that whole thing to the bottom. So this is going to get us 1 over x to the 14th. All right, and that's our simplified answer. All right, and then so we could do the same thing here with r to the 1/4 to the negative 6. Right, write that negative 6 over 1, and then just multiply the top with the top, the bottom with the bottom. And then that gets us r to the negative 6 over 4. And then 6 over 4 you can simplify. Divide the top and the bottom by 2, so we get r to the negative 3 over 2. And then once again, we have a negative in the exponent, which we can bring to the bottom. So that's going to get us 1 over r to the 3/2. All right. And then b to the negative 8 to the negative 3, right? We're going to do this power to a power and multiply, right? We have another b on the outside, but let's do order of operations first, right? Order of operations says to do our exponents first. So this is going to get us b times b to the 8 times 3 is 24. All right. And then from here, we still have two b's, right, that are being multiplied. If you're multiplying two b's, you can combine them, right? So to combine these, we are just multiplying by the same base, which means we need to add our exponents. So 1 plus 24 is going to get you 25, so our answer is going to be b to the 25th power. All right. So this next one, there's a couple of different ways that you could think about it. You could first look at this h to the 7th and see this raised to the 0 power. If you guys remember, anything raised to the 0 power is 1. So this whole thing goes away, it just becomes 1. So we get h to the 2nd times 1, which is just h to the 2nd, which is our answer. Right, another thing that you could have done is actually use the power property to further understand this, right? So we have an h to the 2nd times, and then 7 times 0 is 0, so we get h to the 0. And then from here, you would do maybe your product property and maybe do h to the 2 plus 0, and that's just h to the 2nd, right? So either way, you get the exact same answer. All right, it doesn't really matter how you do it as long as you understand the concepts. All right, let's keep going. So this next one, I have m to the 2nd to the 3/2. Right, to the 2nd to the 3/2 means we're going to multiply those exponents, right? Power to a power, you multiply. So m to the 2 times 3/2. And then you can write this 2 over 1, and then you can either multiply straight across and then simplify, or you can cross cancel, right? If you cross cancel, the 2's go away, and then you just are left with m to the 3rd, all right? And then nothing can combine with that n to the 1/7. Right, it's not a negative and it's not a 0, so you can leave it alone. So this is your final answer. All right. Now the next one, same thing, right? You can do power to a power with x to the 6 to the 2nd, right? 6 to the 2nd is a power to a power, so you're going to multiply. So we get x to the 6 times 2, which is 12. All right, and then with this one, once again, just like the previous slide, you could just say that anything to the 0 power is 1 and get rid of it. But if you use your power property, you should get the same answer, right? So we get x to the 12th times y to the 0, right? 3 times 0 is 0. All right, but then y to the 0, that's just 1, right? So then we get x to the 12th times 1, right? But anything times 1 is itself. So our y goes away completely. It just becomes x to the 12th. All right. And now same thing with number 11, right? So if I have a g to the 5th to the negative 5th, right, power to a power, once again, you can multiply. So then we get g to the negative 25th, all right? And then here we have a g to the 6th to the negative 2, power to a power, you can multiply. So we get g to the negative 12, all right? And we have two g's now, right? These have the same base. If they have the same base, you can add the exponents if they're being multiplied, right? And here they are. So we get g to the negative 25th plus negative 12, right? And negative 25 plus negative 12, they have the same sign, so we can just add and keep the sign. This is going to be g to the negative 27. Once again, you don't want a negative in the exponent, right? So I'm going to move it to the bottom. This is going to get me a 1 over g to the positive 27. And then that's your fully simplified answer. All right, so what we can do for the next one is the same thing, right? So we have a v to the second to the third, right? 2 to the third, you can multiply those exponents together, and then you get v to the sixth, right? Do the same exact thing with w to the fourth to the 1/3. Power to a power, you can multiply. So you get w to the 4/3, right? If you did 4 over 1 times 1 over 3, and then just multiply straight across, you get 4/3. Right, so you get w to the 4/3 for that one. All right, and then w and v are two different variables, right? So that's as far as we can go with this problem. This is fully simplified. I don't see any zero exponents, I don't see any negative exponents, and I only see one of each variable. So this is fully simplified. All right, so let's just keep going with some more examples. These are a little bit different because we have now two things underneath our parentheses, right? So if you have two things underneath your parentheses, then this exponent is going to go to both of what's inside, right? So assuming that these two things are being multiplied, which they are, right? 6 times a, it's going to be a 6 to the 4th, right, times a to the 4th. Right, so we can simplify this a little bit further, right? So 6 to the 4th is the same as 6 times 6 times 6 times 6, right? And then 6 times 6 is going to get you 36, and then I get another 36, so we get 36 times 36. And then let's see what this gets us. All right, so looks like it's, what, 216? And then this is going to get us 1080, so 1,296. All right, so our final answer here is going to get us 1,296 a to the 4th. All right, now on a test or a quiz, if the exponent is too big, like let's say this was 6 to the 7th power, right? I don't expect you guys to do 6 times 6 times 6 times 6 times 6 times 6 times 6, right? That's too many numbers to multiply. We'll tell you to just leave it as an exponent, but you'll know it when you see it, right? And we'll give you a heads up as to what we actually want you to simplify or not. All right, so let's do the same thing with number 14, right? So a couple things that you could do here. You could either distribute this exponent first, or you could take care of that negative first. I personally like to take care of the negative first because that's the thing that I find is most overlooked by the students. So I would first get rid of that negative exponent by bringing this whole thing to the bottom. So it becomes 1 over 5f to the 3rd power. All right, so this is going to become 5 times f, and then you can distribute that exponent to each factor, right? And this only works if there's factors, right? So let me give you an example of something where it doesn't work. If I gave you 5 plus f to the 3rd power, you absolutely cannot distribute that exponent to each term, right? That is incorrect. Similarly with subtracting, right? If I had 5 minus f to the 3rd power, right? You can't just distribute it to each of these terms, right? If it is a term, you cannot distribute that exponent. So hopefully we understand the difference. A term is just anything separated with a plus or a minus. All right, but if it's a factor or something in a quotient, like let's say I had 5 over f, right? Multiplying and dividing is fine, right? I can distribute to each of these. And the same thing with multiplying as we did here, right? 5 to the 3rd and f to the 3rd, that's fine, right? So I can make this 1 over 5 to the 3rd times f to the 3rd, all right? Now 5 to the 3rd, that's going to get you 125, right? 5 times 5 is 25, and then you can verify it. 25 times 5 is going to get you 125. So our answer for this one is 1 over 125 f to the 3rd. All right, so hopefully we understand that difference. I'm going to do the same thing with the next one, number 15. 9 and z are being multiplied, so you can go ahead and distribute those exponents. And then this is going to become 9 to the 1/2 times z to the 1/2. All right, and there's nothing really more that you could do to this. There actually is, like, there's another way. This 1/2 in the exponent actually means something different, right? And you guys are going to learn soon that 1/2 is the same as a square root, right? And you guys have gotten into that radical section in class, right? But 1/2 in the exponent is the same as a square root. So this is really the same as the square root of 9 times the square root of z. And the square root of 9 is 3, right? So we get 3 square root of z as our actual answer, right? But once again, you'll know on your test whether to do that or not, right? And I'll go over more examples in class if that's the case. All right. And now let's do this last one. So once again, I see a negative in the exponent. I would first take care of that negative exponent. So to take care of that -2, I would bring this whole thing to the bottom. All right, so then this becomes 1 over 10m to the third to the second power. All right, and then that 2 in the exponent, because 10 and m to the third are factors, I can distribute that exponent. So this is going to become 1 over 10 to the second times m to the third to the second. Now 10 to the second, I know that that's going to get me 100. And then m to the third to the second, right? 3 times 2 is going to get you 6. Right, power to a power, once again, we multiply. So this is going to get us 1 over 100 m to the 6. All right. In the next video, I'm going to talk about the quotient property. And then we'll do some mixed review, right? Trying to incorporate everything all together.